Let's dip deeper and understand how eventually we're going to discount the future cash flows back to present time to get the value of bonds with embedded options. So the first complication in building a model to value bonds with embedded option is that future cash flows will depend on what happens to the interest rates in the future. There is obviously uncertainty to the future. Nothing is guaranteed, but we will try the best as we can to predict what will be the future spot rates. Now, given the assumed interest rate volatility, which means standard deviation, the square root of the variance, an interest rate tree representing possible. It's important to understand that these are only possible, but probably likely. This is what we believe. Future interest rates can be constructed. So we look at historical data. What is the interest rates in the past year, 2, 3, whatever it is, the time frame that you want to take. And then from that, learn the variance of how much variability there is in the interest rate. What is the standard deviation? We take the square root and try to apply that to the futures with, obviously, it is possible also to embed here some premiums or some discounts depending on our beliefs what will be the future spot rates. The interest rate on that tree are used to, first of all, generate the cash flows taking into account the embedded options, and two, to compute the present value of these cash flows. So first of all, let's see how it is done. Let's understand that also interest rate models commonly used are based on how short-term interest rates can evolve over time. They are referred to as a one-factor model. More complex models exist, but we're not going to get too much into that. And they are called two-factor models. For example, a model that will consider how both the short-term and the long-term interest rates, they are considered as two-factor model simply because they look at both short-term and long-term as two separate things. So the first thing will be to assess what will be the future interest rates. But for that, we need to understand also the concept of a binomial tree. So a binomial tree or a binomial model, essentially what it does is it looks at specific nodes, specific points, and we say from each and every node we can move either up or down, high or low. You will see in different textbooks, or if you will search it on the internet, you'll see that the two notations are applied here, either up or down, and some textbooks are calling it high or low. So from each and every node, we can move either up or down. From each and every node, we can move either up or down or high or low. So this is how a tree is evolved. We are considering from each and every point, a decision point, we're considering that the interest rate may go up, may go down. We don't know that. We're only assessing possibilities here. And in fact, we're thinking that, look, there are equal chances for the interest rate to move either up or down. So we're going to build here two trees. The first tree will be the binomial tree for interest rates. We're starting from the current interest rate, whatever it is today is observed, and then moving forward in time, we will predict what will be the future interest rates based on our expectations, based on our assumptions, based on prior observations, standard deviations from the past, and so on. And then we will predict what could be the future interest rates for each and every period or for each and every year if you want. So if we know current interest rate right now at present time, we will predict what could be the interest rates 1 year from today in the up state and in the down state. And once it will be here, for example, the interest rate in the up state, if the interest rate will move up, then from that point it may move up again or down. So the up again will be called up, and the down over the second years will be called up-down. Why? Because first you have up and then down. This is how we mark those interest rates to be able to keep tracking on them. So up, down, up, down, down, and this will be up, down, and down, and so on and so forth. Predicting future interest rates, we're moving forward in time, discounting the cash flows eventually using those interest rates, we will move backward in time. You will see that in a minute. First of all, the idea. The idea of a binomial tree will be to record first and foremost the interest rate at specific points in time. So from each and every node, we will record what is the interest rate, and then what will be the interest rate in the up state, what will be the interest rate in the down state. Like I said before, some textbooks are calling it either up or down, some are calling them high and low. Same thing, whatever you feel comfortable with. At each and every node, n represents here a node, you need to understand that for options, for bonds with embedded options, each and every node can represent either an event or a decision. A random event means that those are things that are out of our control. For example, the Federal Reserve will increase the interest rate or decrease the interest rate. But a decision, this is the point that the options will take place into account. A decision will make sure that if it is either a callable bond or a puttable bond, then there is some interference. Either the issuer will interfere and buy back the bond simply because it is a callable bond, or the bondholder will force the issuer to buy back the bond if it is a puttable bond. So that's a decision. Just remember, there are points that the decision will be taken, and there are points that it is completely out of our control, and this is a random event. Eventually, we will build this entire tree that on each and every node we will record. There is no need to actually build two trees here. Usually we write one tree and embed all the information on it, okay, just to save time and some space. So we will record on each and every node the interest rate, what's going to happen to the interest rate in the up state and in the down state, in the up, up, down, and down, down, and so on. We'll record the timeline, today, year number 1, year number 2, and so on. Once we'll build or struct this tree of interest rate or spot rates, then we'll write the cash flows, and the cash flows we will always start from the end, because the end at maturity cash flows are certain, we know them. It's always the par value and the last coupon. So we'll start by writing the par value and the last coupon, and then we will start to discount them backward using those interest rates. Just remember, the concept here is that interest rates or spot rates, you're creating them by moving forward in time, but the value of each bond, using both either a random event or a decision, some sort of interference either by the issuer or by the bondholder, we're moving backward in time. We're discounting those cash flows backward in time. And I will show you how. So the valuation process works backward in time, which means we start from the far end, right nodes, time to maturity, and work our way backward towards the left nodes. This is called the backward induction. Okay, let's see how it is done. First of all, on each and every node, we will write either VH or VL if you want at the high point or the low point, at the up point or the down point. VH or VU, if you want, V up, represents the bond's value for the higher interest rates. VL will be the bond's value for the lower interest rates. And C are the coupons, because the coupons are also given to us, and we will consider those coupons also. So the cash flow at a specific node can be either the value at the up point whenever the interest rate is going up plus C, plus the coupon, or VL plus C, the value of the bond at the lower interest rates, plus the same coupon, okay? The coupons are deterministics. Basically, when you want to discount those cash flows to present time, you do either the VH plus C divided by 1 plus the interest rate, and here I left it open to add some time, okay? Are the interest rate at some year number 1, 2, 3, whatever it is, or VL plus C, the value of the bond plus the coupon, you're discounting it by 1 plus the interest rate at that point. So basically, simply because we don't know whether the interest rate will go up or down, we simply take a simple average between the two. So you do this plus that divided by 2, or multiply by half. It's the same thing. Okay? So once we know the value of the bond in the future time plus the coupon, either in the up state or the down state, we're discounting this, discounting that, and then we take the simple average. On your homework practice questions, what I did there over several questions is that instead of discounting this cash flow separately from that cash flow and then taking the average, you can make a shortcut here by adding those cash flows, VH plus C plus VL plus C, and divide both of them by 1 plus the interest rate because it is the same interest rates, and then divide by 2. So mathematically speaking, it is the same thing. Let's see a couple of examples how it is done.